This conference will now be recorded.
So today we will start a new topic. It is Docker. So if you remember in our previous session, in our one of our first session in the demo class, I have explained you about Docker at the time. So higher level we discussed about Docker. What is the difference between virtual machine and what is Docker? At the time we discussed. I told you at the time. So as of now, today we have created many easy to instances. So in each EC2 instance, what we did, we installed Ubuntu, Amazon, Windows, Amazon Linux, Windows, many OS we have installed. So these are all on the left side. These are all nothing but your EC2 instances. So it's a virtual machine. It is a EC2 instance. So every EC2 instance will contain its own guest OS. In Docker, I explained Docker is a company. They have developed their own product. So they call it as a Docker. So this Docker, what they did, they improvised it. They have improvised it. What they did, so in the virtual machine, we have compulsorily we should have its own guest OS. Every EC2 instance, whenever we create, that is the reason we have to select a OS, right? Right. So, and I told you that OS itself consuming more space rather than more than our application itself. Our application, if you deploy Java, it takes around for example, 1 GB. Then our OS itself taking more than 20 GB. So to improvise it, so Docker, like Docker, we have another company, another software called from company Rocket. So Rocket also a same type, same like Docker. But why we use Docker, we'll try to understand today. So Docker improvised it, and what it did is it has removed the dependency of guest OS. It has removed the guest OS completely. Instead, uh, we have to use a software called Docker Engine. So Docker Engine, actually when you install Docker on your machine, right, it will install two different components. It will install two different components. One is a client component, another is your server component. Server component. So what is client, what is server component? I will explain you in a minute. But here the Docker engine, what it do? Actually, a Docker engine is nothing but we have multiple names for this. Actually, the Docker engine. See, when you install Docker, to install you will install Docker client and it will install Docker engine. So this engine you can say it as server, Docker server also you can say. You can say Docker host also you can say, or you can say daemon. So whenever I say Docker engine or Docker is server, Docker host, Docker daemon, all are same. So when you install, these two components will be installed. When we install Docker software, below, okay, below two components will be installed, right? So Docker client, we use Docker client to communicate with our Docker engine or Docker server. Why we want to communicate with this engine? What is the requirement? That also we'll try to understand in a moment. But as of now, try to understand. We will be having Docker client. Whenever you want to communicate with your Docker engine, you can communicate. Here, here is a Docker engine. Whenever you want to communicate with it, you can communicate with it. So, and next thing is, here each partition we call it as a virtual machine. Here we call it as a container. Then what is container? So this Docker engine, see hypervisor, you see here on the left side is hypervisor. Hypervisor is a software. Hypervisor knows how to create partitions on a physical machine. How to create a logical partition in a physical machine, hypervisor software knows. And hypervisor creates a boundary for this partition. That means in this boundary only your application and its supported binary files, library files, its guest OS will be living in this logical partition only. And another logical partition, it having its own private space, uh, it cannot cross its boundary. So that way hypervisor will maintain here. Similarly, Docker engine also creates a partition, but we call it as a container. We call it as a container. Then what is container? So before you understand what is container, for example, on Windows machine, if you deploy two applications in Windows application in Windows software, suppose you deployed two Java applications, web applications, and these two are using, right, are using different Java runtime. They are using different Java runtime. Runtime also having versions. Deployed two Java web applications and they are using different Java runtimes. At that time, the application will not run. They will crash because there are two runtimes running in the same system. So for that reason, what we did, we went for virtual machines. So in this one application, first application will be running, and second application will be running over here, and they both have their own runtime versions, Java runtime versions. This way, we can provide stability to the Java web applications because every application running in its own virtual partition. You cannot install both applications without virtual machine. If you install the same machine, that is, if you're having only host OS, no guest OS, if you're having only one host OS, then in the host OS, it you have installed two runtimes. Java two runtimes you have installed. When you deployed application, Java application on the same host OS machine, then the applications crash because they could not choose the correct runtime environment because both are running on the host OS. So that is the reason we go with the hypervisor and we did the partitions. So similarly here also the same advantage we get. You can deploy your application in different containers, right? So if you do the same thing on Linux machine, you won't get any issue. If you do the same thing on Linux machine, you won't get an issue because internally Linux is very advanced actually. Actually, the Docker has been inspired by Linux operating system. By seeing the Docker only, by seeing the Linux architecture, they have developed the Docker software. So in Linux machine, normally what they do, we will hear in Linux machine commonly. If you are very familiar with Linux, then you will be hearing about namespacing. Namespacing. So what is namespacing? So it's like it's a isolating resources per process or group of processes. So isolates resources per process. So this resource can be your Java runtime also. That means even though you have installed two Java applications, every application will have its own namespace. First Java application running in its own namespace and another Java application running in its own namespace. Then what is namespace? It's an, we can call it as an isolated area. It's an isolated area of execution. Isolated area of execution of your process or processes. So here, if you deploy two web applications, two applications will have its own namespace and they will have their own resources for them. Only those resources allocated for them. For example, if first Java runtime requires Java one runtime version 1, for example, and another one is Java runtime 2, for example, then you deploy two applications. There will be two namespaces, and in the first namespace, Java will be running, and its associated Java runtime will be running along in that same namespace. And similarly, there will be another namespace. In that, another Java application will be running with a runtime 2, something like that. So isolating resources per process. So what are those resources? For example, what are the resources? Resources which our namespace maintains. Resources can be many. For example, if you take few of them, like your processes itself, your hard drive also comes there. Hard drive also a resource. That means your Java application will use the hard drive. How much it has to be, how much it has to use, that is again controlled by another another group called control group. I tell you that in a moment. So hard drive, network. So some, so when you're running Java application, then the Java may be depending on other processes. So some processes are allocated for that Java. Some hard drive also allocated some part of hard drive, and some part of network will be given to it. Not full network, some part, some users who can access it, some host names, so which servers it can connect to, and inter-process communication. That means one process can communicate with other process. So if it want to communicate with other process, so can it connect to, can it communicate with that other process or not? So all those restrictions you can provide, okay, using our namespace. So these are all the various resources which comes under a namespace. So namespace allocates these many and many more resources to our Java application, and namespace saying that okay, you can use these processes, you can use some hard disk, hard drive, some network, some users, some RAM, etc., etc., and then it's okay, you associate given this to that Java 1 application. Now assume, now Java 1 application may use more hard drive, more hard disk space, more RAM space. So how to control it then? Namespace separated. There are two Java applications. Every Java application will have these resources. Now you can deploy any number of Java applications. Namespace will take care about it. It will create a isolated area. It will create a isolated area. And how to control? They can over consume the resources. To control it, in Linux machine we have a group called control groups, or in short we call it as C groups. So what it do? Limits the amount of resource used per process. So it will control like how much that particular application running in one of the namespace, memory, how much memory it can use, how much CPU it can use, right? And network bandwidth, etc. So we have namespacing and control groups in Linux. We don't have this in our Windows. So by this inspiring by this Docker company, they created a software called Docker. So what Docker will do is, so it will create a namespace. It will create a container. Container is nothing but a, it includes same like our Linux environment. The container will contain same like our Linux kind of environment. That means in this picture, here is your guest OS. Here is your guest OS. When you install Docker, a Docker client will be installed, component and Docker engine will be created. Actually, this Docker engine contains, actually it contains Linux operating system. A tiny mini Linux operating system will be there in the Docker engine. So that means whatever container we are creating, those are created by your Linux machine. So whenever we install your Linux Docker on any machine, on Windows, we can install your Docker on Windows operating system, your Linux machine, wherever you install. Then as I told you, two components will be created. Another component is Docker engine. This contains the Linux operating system. So here you see every partition having their own guest OS, but here there is only one Linux machine. It contains one Linux machine. On top of it, on that on top of that Linux machine, these containers are created. So that means, for example, so if you take this example, so here we have installed our on these are Windows, for example, these are Windows, okay, and on top of it we have installed our Docker, we have installed Docker, right? So when you install Docker, this is your Docker engine. Your Docker engine is nothing but a Linux virtual machine. It's a Linux, it's a Linux virtual machine, and on top of it you will create your components. You will create your components. Sorry, your containers. This is your container, right? So these are containers now. So, and as you know, in Windows or in Linux machine, you should know what is kernel is. See, your Windows operating system, suppose I clicked on a mouse button, I clicked on a keyboard. Whenever you click it, then the request will be passed to kernel by Windows operating system. Your Windows operating system will pass a request to, will send a request that a key has been pressed, a particular key has been pressed. That message will be sent to kernel. Kernel is again a software. Okay, there are, if you see in naukri.com, if you Google there, if you if you search for kernel developers, you will find jobs for them also. So we call them as device driver developers. Device driver developers. So nothing but device drivers means nothing but kernel development, right? So kernel also is software. So the kernel is a software which will actually communicate with your hardware, which will communicate, actually it will communicate with the hardware, and it will it will direct it to what it has to do. So now keyboard is pressed, then the kernel will send a request to the particular software related to that particular keyboard software. It will inform to that keyboard software that if this has been pressed, then that software related to keyboard will take the action and give the response back. So whatever action it can be, then that sent back to kernel, and kernel will send back it to Windows operating system. But anyway, here also we have our container, and in this container, now between these all these three containers, we will have a Linux kernel. Here we will have our Linux kernel. This is your Linux kernel. Just a moment, please. I want to reply to a message. Thank you. So here this is your container. Your container will, for the first container, the second container, and third container. So every container will have their own resources allocated by namespace. So every container will have their own process. Like here, I'm in short, I say process, hard drive, like that I said. But actually, they have process manager, a software like Linux machine having a process manager which handles all the requests, network manager, storage manager, which deals with your hardware, file system manager. Same like how a Linux works. Same like every process will have all these resources associated with it. In the namespace, all this will be available. And your finally, finally, the application related binary files and library files. So this all, if you group together, your container will contain all of these. So in this picture, not this one. So here, if you see application A is there, it's having binary files, library files. Here also you see application binary files and library files. Along with this, every container will have their own process manager, network manager, storage manager, file system manager. Many are there. So it's all comes under namespacing. So how much process can be used, how much network can be used, how much storage can be used, are all controlled by C group control groups. It will limit. That means every container will be restricted when they are using the resources by the control group, and every container will have their own namespace. So whenever a request comes, whenever you want to communicate with the operating system, the container, the request goes to your virtual machine. And finally, the virtual machine is actually one moment please. It's complete your, it's complete your Linux operating system. So here the request, now from their Linux machine the request go, okay, the diagram I should have not did like this, should not have done like this. I think it takes tag, right? So these are the containers actually. So these containers end here only. This one container, this another container, this another container. These containers actually communicate with our virtual machine, kernel, to our Linux kernel, right? Then our Linux kernel will communicate with our Linux virtual machine. So that means the complete Linux environment is available. When you install Docker, then Linux will be installed, and these containers are controlled like as we do in our original Linux machine. In a Linux machine, how we can deploy multiple web applications with different runtimes, how it manages on the Linux machine, the same way we can manage here. So every container is an isolated area. It's an isolated area means it contains required execution environment. That means you can bring a software into the container, you can execute it. Like for example, I am on a Linux machine, I am running yum install Apache 2. When I say Apache will be installed, right, the same thing you can run that command in your container. So it contains everything, all in when how to execute that command, it contains all the required environment. It should have that environment. Any questions please? So when you do it practically, you will understand it more better, right? So if you want a definition, then we can write something like Docker is a platform or ecosystem around creating and running containers. Like in this picture, as hypervisor know, like your hypervisor know how to create a virtual machine, your Docker engine knows how to create a container. That means whenever you want to create a container, Docker is a platform or ecosystem around creating and running containers. So your Docker software will create the containers. Whenever a container is created, the container will have the all the required namespaces and control groups. The Docker will create such an environment inside the container. It will contain all the required environment. It will have all the execution environment. The container will contain the execution environment. Now your container is ready. Now in that container, you can bring any software and you can install inside your container. For example, to make you very to clarify this very simple, then I tell you one example. Like when we are doing custom images in on AWS cloud, what we did, first of all, we created a virtual machine, EC2 instance, I mean to say. In that we have deployed we deployed a web application, and then we converted it to a image. We have converted that to a image, right? Now the image contains what? It contains the OS, the application, and the Apache web server. These three are contained inside that image. Now that image, what we did later, we created one more instance by using this image. So your cloud provider created a virtual machine, and in that virtual machine, he taken our image, our custom image, and he executed that image in that particular new EC2 instance. Then automatically in that instance, whatever we expected, that means our web server is available, our application also available. So second time we have not reinstalled these softwares, right? Your cloud provider taken our custom image and executed in a virtual machine. The same thing your Docker engine will do. To our Docker engine, we will provide a image, and your Docker engine will do what? It will create a container, and into that container, it will execute this image, whatever image we provide to our Docker image, sorry, Docker engine. Then that image will be created inside the container. Same ditto. And here this is a virtual machine, and here under the virtual machine, what we have? Our Windows OS. Same like if it's a picture. So Docker engine, and then under that we have the host OS, and below that we have the infrastructure. The same thing. The same thing I am trying to explain. Your Docker engine, but this Docker engine, this part I have little bit elaborated. So your Docker engine is nothing. It's not a simple Docker engine. It's a Linux virtual machine. It's a Linux virtual machine, and this Linux virtual machine have its own Linux kernel, and your containers will communicate with your Linux kernel, and they Linux in turn will communicate with your Linux virtual machine. So Linux virtual machine is nothing but your Docker engine. Docker engine comes with your Linux operating system with many more, with other things as well. Among them, Linux virtual machine also will be there. So, but in this picture, it is only saying Docker engine. This part, this part I have elaborated here. That's all. So that is about it. And now next thing is uh, where we find the images. Of course, custom images, I told you we create the custom images, and those custom images are deployed in our virtual machine by the Amazon cloud provider. Then where we can create our custom images, see, Docker already provides a lot of custom images in their website. They have their own website called Docker Hub. If you type Docker Hub here, you'll get a website called Docker hub.docker.com. Hub.docker.com. If you go over there, then okay, here search not that one. Where is that? This UI has been changed now. Okay, explore here, or let me check one moment. Let me sign in. So you can sign in with your Google account or with your con- continue with GitHub, or you can sign up. You can sign up. Okay, click on sign up. You can sign up with your Google account or GitHub account. Okay, just give your when you can select GitHub and you can give your email ID. That's all. When you click on GitHub, it will ask for your username. On your GitHub, you have your username, right? That username it will ask, or else you can create your own email ID and password also. You can do that way also, or else you can use continue with Google account also. You can do it. Since I have already my account on this, so I am signing with it. So one moment, sign in, and I have to sign with GitHub. Then it will ask my GitHub username. Okay, it may have cookies. It is selected. So here when you log in, on the left side you see we have explore button. What is repositories? Repository is nothing but we can create our own images. We can create our own custom images which we did already, right? When we learning AWS, in that at that AWS services, at the time we create our own custom image. We will see that how to create our own images. Whenever you created your own images, then those images you can upload to this Docker Hub. This Docker Hub is like our GitHub. You know what is GitHub? GitHub stores the raw code, and you know JFrog. What it stores? JFrog stores binary files or artifacts. Now this is same kind of repository, Docker Hub. In this Docker Hub, you can upload your images. Okay, when you created your own image, you can upload them and you can download them whenever you want, or you can share with those images with other teammates. Those things we will learn slowly, but now repository is about it. When we discuss about creating images and uploading, that time we revisit this part and click on explore. When you click on explore, you can have we have many what do you call images available already here. So these are the different messages, different images. If you know the names, you can pick it one. So Alpine is an image. Alpine is a minimal version of Linux operating system. You see a minimal Docker image based on Alpine Linux with complete package. So whenever you want to install a Linux machine, Linux operating system in a container itself, you can do it. So don't think that because normally when you install Linux machine operating system, normally it requires 4 to 5 GB, but these images are squeezed actually. So only required functionalities are available in these tiny images, which are enough to run your applications. For example, here instead of installing the complete guest OS, you can use our Docker image. The Docker image are squeezed versions which will be come with very less space. Like that, you can have our own what you call Apache. Okay, you can have our own MS SQL. Many are there. You can, if you search, we have many OSS images are there. For example, you can have Ubuntu also. If you want Ubuntu, you can type Ubuntu here. See, when you click on Ubuntu, so see Ubuntu how much size it is taking, around it will show somewhere here. Somewhere size will be there, the size of this image. So what is this? So Ubuntu, what it is? Ubuntu is a Debian based Linux operating system based on free software. So that what I'm saying, trying to say here is that we can, in this container, we can deploy Ubuntu as well. You can deploy Ubuntu operating system in this, and then on top of it you can deploy our web applications. So This Ubuntu will take very low space. It will take very low space. So using Docker, we have another advantage that Docker makes makes it really easy to install and run software without worrying about setup or dependencies. So a image comes with all the dependencies. An image comes with all the dependencies. You don't need to worry about dependencies. So in short, hope you understood. It is same like our virtual machine only. But thing is, in this virtual machine, your AWS cloud will deploy the images, but here your Docker engine will deploy the images inside the container. Container is nothing but a isolated area, and you can execute images. You can execute images in that. That means your images can be running inside a container. Such place we call as a container. And here is a virtual machine or EC2 instance. In this EC2 instance also, we have created custom images. These custom images, when we creating a new EC2 instance, at the time we have selected our image name. At that time, your cloud provider understood that okay, this person want to use this custom image to be deployed in my new EC2 instance. Then cloud provider will create what he will do. He will first create EC2 instance. When he created EC2 is nothing but a partition. A partition he will create. In this partition, he will provide all the and such an environment that in that partition the cloud provider can deploy our custom image, and our custom image will be executed inside this partition. So before executing that image, custom image which we created, this partition should have such an environment. That environment will be provided by the AWS cloud provider. You will take care by using the help of hypervisor. Hypervisor will do that job. It will create a partition. It and a partition in that partition, it will hypervisor will provide such an environment that the custom image will be deployed here. And once it is ready, then you are ready to use the application immediately without installing anything. Similarly, here also, here we have a Ubuntu image, for example. This is Ubuntu image. I want to install this Ubuntu image in my container. Then I have to tell to my Docker engine. I should say that I want to install Ubuntu in a container. Then which container, what container you need to mention. Your Docker engine will take care of everything. It will create a container immediately, and it will create the required environment like Linux kind of environment, like namespaces, control groups, everything it will provide, attach all the resources to this container. After that, what image you want to run inside it, you have to mention, you have to tell to Docker engine, you have to tell to Docker engine. And Docker engine will do what? Actually, Docker engine will have its own space, its own space where it stores the image list. Docker engine will store the image list. So Docker engine will check whether the in that the wherever it store the images in that whatever image, suppose you want Ubuntu image, is that Ubuntu image already available? It is not available in this machine. Then Docker engine will automatically connect to our up.docker.com, this website. It will connect to this machine, this website, using a web API. So web API is again programmers can understand. So it will give a call. It will like in AWS CLI. When we learned AWS CLI, at that time we listed out bucket list, right? S3 and bucket name and LS we said, right? So similarly, that's a command. Automatically it connected to the AWS cloud. Similarly, Docker engine also connects to this hub, and it will download the Ubuntu and will download the Ubuntu image. See, it will internally call this command docker pull Ubuntu. What is pull and what is push we will understand in coming sessions. But finally, what I'm trying to say is that your Docker engine will pull that image from the Docker hub, and that image will be loaded inside the container. That means Docker engine will do two tasks. One is it will create the container first, and the container will be created with the required environment with namespaces and control groups. And after that, the Docker engine will check whether already Ubuntu, suppose you try to create one more container with the same Ubuntu software image, for example, because already Docker image has pulled it from the Docker hub. Next time it will not pull it from the Docker image, because that the images whatever it has stored, pulled from the Docker hub, the Docker engine will store it in a separate location. All the images it will store at separate location. We will see that where it stores. So once it stores there, second time when you want to use the same Ubuntu image, then Docker engine will not pull it from the Docker hub. Instead, it will check locally whether it has already pulled it or not. If it has pulled it, then it will use that image and it will upload that image into the container. So container, don't confuse. Container is nothing, very simple. So it's a execution environment. It's a execution environment of any image, right? So and image, what is image then? Image, as I already told you, it is nothing. It is nothing but what it is. It's nothing but a mix of, see, it's mix of applications and binary files. Here we created a custom image. In the custom image we download web server, we download web application, and we installed it, and we deployed it, and then we converted it to a custom image. Now if I ask you what is custom image, then what you will say? What the custom image contains, then what you say? The custom image contains the operating system which we have selected, and the Apache web server, and we downloaded that web application, and we deployed it. Then if I ask you what is that image contains, means you should say what? It's a mix of the web application. It could be web application or it could be any application, right? That is the reason I should not mention as a web here. It can be web application or it could be any other application, right? And what are the dependencies of this application? Web server, right? In that example, in that context, if I talk in the custom image, we have application and we have web server also, right? So instead of mentioning it web server, I simply say dependencies to run this application. Our web application depending on what? Web server and Java runtime or any runtime, right? Some libraries, etc. So that is image, simple image. It's not at all complicated, very simple, because you already did it. The only thing is platform is changing here, that's it. Platform from virtual machine to we are shifting to container, that's it. That is the only difference. Previously these virtual machines are maintained by hypervisor, this time Docker engine is maintaining.
Hello, hello, Madan.
I'm sorry, Rajesh. Yes, Rajesh. Yes, yes.
Yeah, yeah,
Please
your
go ahead.
voice is not audible.
Thank you, thank you. I was on mute. Thank you.
Your,
Container is a isolated area of execution. Image is a it is nothing but a mix of application dependencies, some libraries, etc. And Docker is a platform or ecosystem around creating and running containers. Okay, Docker makes it really easy to install and run software without worrying about setup or dependencies. Okay, these things you should understand. So there is no Docker, there is no container. If there is no container, there is no use of images. Okay, right. So that is okay. So you can compare Docker with your hypervisor. You can container your container. You can compare with the container with your virtual machine, and your image is you can compare with our custom image. We already created custom images in your previous classes. So Docker is running now. Select it. Now paste here. Now Docker. So how to install Docker here? Simply you say yum install Docker. Yum install Docker -y. And then this is service, so we have to start the Docker service Docker status. For example, if I say, you see, when I say service Docker status, it is saying active, it's inactive, it is dead. So we have to start it. So up arrow, click on start. Service Docker start. Now it's starting, and again let me check status now. Now you see it is active. It is active and running. Okay, it is active and running. Okay, so install Docker, right? Yum install Docker -y. Okay, then you have to start it. Start service, right? So which service you want to start? I want to start a service, name is Docker. I have to start it, and then I have to, no need to check it, you can check it if you want. Status, you can check it. Okay, this way you can do. Control C. Now if you see the version, Docker version, when I say Docker version, you see here a client is there, a server is there. And if you observe carefully, what is the OS the server is having? OS architecture is Linux. So it internally uses Linux operating system, and this client is developed using Go language. Say it developed using Go language. Go language is used to develop even Kubernetes as well. Okay, so it is another Go version. This all both are used with the same Go version. So who are developers, they can learn Go language and they can write Kubernetes code. They can write extensions for Kubernetes. That is another topic. So this is developed in Go language, and this is a version. Engine version is 25.0.3. So client and server both are there. By the way, client is nothing but, see, what you do. This is your client, and this is your Docker engine. That means Docker engine, right? So here is this a Docker client. So from here, from your Docker client, you can give commands. You can send commands to your you can communicate from your see from your from my free screen. Here I have my Docker client. This is a client. From my prompt I can communicate with my Docker. This is a Docker engine. This is a Docker engine. Sorry. This is a Docker engine. And from the client, this client is nothing but your what do you call your console. From your console you can request whatever you want to do by the Docker, what do you call, Docker engine. So what request I want? Suppose I want to install a small engine, a small image in a container. For example, when you're learning any language, programming language, normally we write this hello world kind of application. Here also we have hello world kind of image. You see hello world image. This hello world is a small image. Hello world, an example of minimal Dockerization. So I want to install hello world application, for example. This is an image. That means I want to ask my Docker engine that create a container, and in that container install a image hello world. And hello world is a program, pre-written program. It will display some output. It will display some output. So before you execute any commands, you can see what commands are available. Container, Docker container, hyphen help. If you type this, you will see the other commands available. Attach command, commit, copy, create, difference, execution. These are various commands available. And out of this, if you want to use a command called run command, for example, create and run a new container from an image. Create and run a container. A container should be created and it should be running. It should be running with what? With a image. What image? That image you have to specify. Now, when I say Docker, if I use this run command, and then image name, you can use this image name. This is a hello world image. You see, hello world image. This image name you can copy and you can paste here. Now, if I press enter button, what happens? This command actually is going from your client. This command is actually going from your client. From here it is going. That means here you are saying from your client, you are saying that Docker run hello world. You are saying like this. When you do this, your Docker client will send this request to your Docker engine, and Docker engine will do what? Docker engine maintains a list of images. It maintains a list of images. Okay, list of images. If this when this client send a request to Docker engine understands, okay, you want to create a container, okay, and in this container what image you want to install? Okay, hello world, no problem. Is hello world available already in my image list? No. Then if it is not available, then Docker engine will do what? It will go to hub github sorry Docker hub. It will go to Docker hub, and from there it will pull the hello world image from the from the repository where Docker hub maintaining all the images. From there it will pull it, and once it pull it, that means it will go to your Docker hub. This is your Docker hub. So Docker hub contains all the libraries, all the images. Once it is pulled, then next time it will not pull it again. If you have the same image, your Docker engine will not pull it. Your hello world image will be stored in this list. If you next time, if anybody want the same image, this time Docker engine will not go to the Docker hub. Instead it will pick it from here itself. So let us run this command. Press enter. Now you see unable to find image hello world latest locally. It is saying hello, it has not found the hello world locally. Latest, it is pulling from library hello world. So pull complete. Then hello world displays a message. What is the message? This is a message it has displayed. So in this display, it is explaining what has happened. It is saying that hello from Docker. This message shows that your installation appears to be working correctly. So to generate this message, Docker took the following steps. These steps it has followed. These steps it has followed. The Docker client connected the Docker daemon. Daemon or Docker server all are same. So your Docker client connected to a Docker engine or Docker daemon. Okay. After connecting, the Docker daemon pulled the hello world image from the Docker hub. Okay, it has pulled it. Alright, then the Docker daemon created a new container from that image, which runs the executable that produces the output you are currently reading. Right, this output it has that image has produced. The Docker daemon streamed that output to the Docker client, which sent it to your terminal. So this is the output you are reading. This how the Docker daemon displaying here. That output it sent it to Docker client. That means your Docker daemon deployed. It created a new container. It executed that hello world in that container, and the container. uh, This image is running inside a container. This image has produced some output. That output received by your Docker daemon, and that output again given to back to your client, and your client will display that output like this. This is the output we got. So if I run the same example, same command again, you observe what is happening. See, I ran the example again, but directly I got the message. But before the message, some steps are not there. What are those steps? So before hello, these are the steps. These steps we are not seeing now. Why? Because unable to find. No, this time it will find it because it having the image locally. It saved it. It will not pull it again. That is the reason it is showing immediately. Now in the above example, like help, this is a run command. Now a image is pulled. I am saying that a image, hello world image is pulled and it's stored locally. I am saying, but can I see it? Yes, we can see it. How I can see it? We have another command called image. Where is that? Right? We don't have that right here. So then let me. No problem. You say Docker. Docker. We have a command called images. When you say Docker images, then it will display the images. You see, hello world is an image, and every image will have a ID. And when it is created 12 months ago, it's a old image. Every image will have a ID. Now suppose many more are there actually. Very interesting things like controlling, downloading the Ubuntu and getting inside the Ubuntu and installing some software in the Ubuntu. Those things we'll do tomorrow. Okay. So today we'll end this today. If you have any questions about today's topic, please come with questions tomorrow. We'll discuss on those. Okay. I hope you are understanding. If any questions, please let me know. Otherwise we'll drop in a minute. So please go through this. It's very simple concept, not at all complicated. From tomorrow onwards, we will be doing all the practicals. You're learning various things. You practice them immediately. Only then you will get confident. Even though they are very easy, practice regularly. Okay. Okay then. We'll drop today. We'll connect tomorrow at same time. Thank you for your time. Take care.